Good morning, ladies and gents. So today we're going to be learning about how to factor what I like to call, and probably someone else likes to call, a complex trinomial. Excuse my really bad writing. Okay, so what makes it complex? Well, let's take a look at what we've been doing. So what we've been doing so far has involved looking at a trinomial. Here's my squared term, my linear term, and my constant term, right? But I'm not sure if you clued into this, but every single factoring of a trinomial that we've seen so far, if you were to look at the coefficient of your squared term, it has always been a 1. And that's what allows us to quickly factor this, right? I know I'm going to have an x in my first spot in both brackets when I factor this, and I'm looking for two numbers that will multiply to give me 2 and add to give me 3. And so I know that that's going to be positive 1 and positive 2. And so now it's factored, right? So that's the simple way to factor if you have a simple trinomial, right? So that when the coefficient of the squared term is 1. However, many trinomials are not going to have a coefficient of 1 beside that squared term. And so those we would say that they're in the form ax squared plus bx plus c, and a cannot be 0, but also we're going to look at a also not being 1, okay? All right. So when the coefficient of that squared term is not 1, the process is a bit more complicated, and that's what we're going to look at today. So, but before that, I want to talk to you about something that may look like a complex trinomial, but maybe doesn't have to be if you see something. So I'm going to write out this trinomial right here. I'm going to write out, 2x squared plus 6x plus 4. And so, at first sight, this looks like it's going to be a complex trinomial because my squared term has a coefficient of 2. But what is the golden rule of factoring? Well, the golden rule of factoring is that you always look to remove a common factor first. And so when I look at this, I'm seeing that each of my values here are divisible by 2. So that means that, I can pull out a common factor of 2, and then what I'm left with turns out to be a simple trinomial that I can factor using the methods that I've already learned, right? Just like up there. So, sometimes what looks like a complex trinomial is not really one if you remember to remove that common factor. Now, let's move on to our lesson. And so I'm going to teach you two methods to factor complex trinomials. And hopefully you'll pick the one that works best for you. One is a sort of a really broken down into bare principles method. And the other method, I've called it my method or Miss Muse's method, but it's really sort of a let's not think about it method. Let's just use this quick trick method. All right, but let's start with the decomposition method. And at the end of the day, I want you to pick one of the two methods, the one that you like the best, that you feel most confident with, and just go with that. All right, and so I've given us a sample trinomial to take a look at. And I've written out a list of steps to take for the decomposition method. So the first step is as always, is to place our terms in order of descending degree. So that means, the highest degree term to the lowest degree term. And so let's just check our trinomial. Yep, squared term, then my linear term, then my constant term. So yes, I can check that off. I have fulfilled the requirements of that step. All right, next step. My next step is to remove the common factor where possible. Now, of course I'm going to do that. Why? Because that's what I should always be doing whenever I'm factoring. The golden rule is remove your common factors. So let's take a look at this trinomial. I have a coefficient of 2, a coefficient of 7, and a coefficient of 3. So in this case, there is no common factor to remove, And so I can say that I have taken a look at this trinomial, and in fact there is no common factor to be removed, so I've accomplished what needs to be done before step number 3. All right, let's look at step number 3. Now this is a big one. So I want you to pause the video and I want you to write down this little piece of information first before watching what it is that I do. So this step is going to be a lot like the first step, the step that we took with our simple trinomials. Okay, so you're going to find two numbers that will multiply. I'm going to do this up here. Two numbers that will multiply to give you your last term. Nope, not exactly anymore. We're going to find two numbers that multiply to give us the product of our first and last term. What the heck does that mean? Well, it means I need to look at, well, here's my last term, and I need to look at the coefficient of my first term. And so instead of just looking at the 3, I have to look at both the 3 and the coefficient of my squared term. So really now I'm looking for two numbers that multiply to give me whatever 2 times 3 is. Okay? In other words, I'm looking for two numbers that multiply to give me 6 instead. And as a side note, let's think about what we would have done before. I'm going to use the example we had just above. Oops. And it was this guy, right? Well, in this case, I would have looked for two numbers to multiply to give me 2 as well, just my last term. But what was the coefficient of my squared term? It was 1. So I'm really, anytime I multiply anything by 1, it doesn't change the value. So really, I was still doing this with my simple trinomials, just not really thinking about it, right? 1 times 2 gives me 2. So now, because my coefficient of my squared term is no longer 1, I need to multiply by that value as well. So 2 times 3, so two numbers that multiply to give me 6, but also add, and this part stays the same, they will add to give me 7. Okay, so what has changed is now that I'm multiplying, I need to find out the product of my first and last term instead of just my last term. All right, so now I've accomplished that little bit. So let's figure out what those values have to be. Now, wanting to make this example fairly straightforward for us, I'm hoping that you saw that the numbers have to be 1 and 6. 1 and 6. Those are the factors that work in this case. So now, well, what do I do with those? This is what the new part is. So I'm going to use these two numbers to decompose my middle term. Okay, I'm going to take my middle term and I'm going to decompose it. So let me rewrite that equation first. So the equation that I started with, let's refresh our memories, oopsies, was 2x squared plus 7x plus 3. So what I'm going to do in this step, instead of writing 7x, I'm going to decompose it into using the numbers that I found above, into 1x and 6x. Okay, let me do that. So, oops. So 2x squared, right, plus 1x, or just x simply, plus 6x plus 3. So we call this decomposing the middle term because, as you'll see, instead of writing 7x, I've now got it written as 1x plus 6x, and so in doing, I have not changed my equation at all. I've simply just rewritten it in a different form. Okay, so that's what the next step is. And so the next thing I need to do, let's take a look at our list. And this part we've already prepped you with. You know how to do this, hopefully, or at least you have some familiarity with it. You're going to factor by grouping. So whatever it is that you did, you're going to factor by grouping, same as we would have in some of our previous lessons. So let's take a look at that. So again, all of these guys are playing in the same playground, but we're going to group some playing together. So I'm going to make this a group and I'm going to make this a group. And I could have rearranged them into different groups, and that should work as well. So now when I factor by grouping, you'll remember that I need to take the common factor out of the first group and also out of the second group. So when I look at my first group, I can see that I have an x squared and I have an x. So numerically speaking, the coefficients do not have a common factor. Only my x is in common in this, so I'm going to pull out that x. And then I write the leftovers in my bracket. So I've pulled out one factor of x, so I have 1 left inside my bracket. And then I pulled out the x, so I'm left with simply 1. And if I go ahead and I expand that again, right, if I go ahead and go back, then I end up with what I started with. So that's a good check. Now what I'm going to do is I'm going to do the same thing with my second bracket. I see that I have a 6x and I have a 3. So they don't have an x in common, but they are both divisible by 3. And so I'm going to pull out my 3 as a common factor. And then I'm left with 2x plus 1. And so remember that a good way to check to see that you've done things right is that your two brackets should be identical. And if they are identical, then that means the process that you've done is correct. So now I'm going to pull out that common factor of 2x plus 1. Because it's a common factor between both. And what's left? Well, I've got this x and then a positive 3, so x plus 3. And so there I've factored my trinomial, and I'm done. If I wanted to, I could go back, I could FOIL this, right? I could FOIL it to check, and then I should end up with what I start with. Okay? So just to recap these steps, okay? I had to find two numbers that multiplied to give me the product of my first and last term. That was 6. And then the add to give me my middle term, 7. And those numbers were 1 and 6. I take whatever values I found and I use it to decompose my middle term using those numbers. That's why they have to add to your middle term. Then I group and factor by grouping. I should end up with two identical brackets, which I do, pulling that out as a common factor and then writing the leftovers in my second bracket, and I'm done. So that was quite a lot. So take a minute maybe to pause and make sure that you make sense of those steps before I show you my second method, which you may find speedier but sort of less about why the math works. Okay, so now I'm going to introduce you to what I have called Miss Muse's method. It's not my method. In fact, I'm fully plagiarizing someone else's work, just to acknowledge that. I learned this when I was out teaching in BC, and I thought, well, it's a quick trick. If you're really struggling with the decomposition method, this is an alternate method that may work better for you. And so at the end of the day, you need to pick the method that you prefer the best. So let me call this, I'm going to just call this the quick trick. Quick trick. Look at my poor penmanship. Trick. Whoa. And spelling, apparently. Here we go. So, all right, so let's just check off a few things that we need to do that are not really different from the decomposition method. The first is that we're always going to write the trinomial in proper order and remove any common factors. That's like a standard issue item. We're always going to want to do that. Okay, and as before, we're going to do the same thing as we just did. We're going to say, well, we need to find two numbers that multiply to give us the product of the first and last terms. I'm using the exact same example as we just saw. So two numbers that multiply to give me 6, but they will add to give me my middle term, 7. And of course, we found those numbers before. They were 1 and 6, and those work for both. So this is where things get different. So I want you to take a minute to write down my instruction. It says take the two numbers you have found. So in other words, my two numbers are the 1 and the 6. Those are the two numbers that I found over here. I'm just writing them out. And you're going to divide by the coefficient of the first term. So, well, where do I find that? In other words, the squared term. So what is the coefficient of my squared term? Well, that is a 2. So I'm going to go ahead and I'm going to divide by 2, both of them. Okay? Now, you'll notice in this case that I end up with a fraction 1 over 2, and I'm going to talk about what to do with that. If I had a fraction that was not in lowest terms, I would need to reduce that to lowest terms. I also see that with my second value, 2 divides evenly into 6, and so I'm actually going to write that as a whole number. I'm going to write that as 3. Okay? So that is the first part of my quick trick. So again, I've got these 2 factors now. I've got 1/2 and I've got 3. Now, take a minute to write down the next instruction. Okay, so what I'm telling you now is that these numbers, we're going to use these numbers, the 1/2 and the 3, to construct our little factors that we need. So let me show you, and then we'll see. So I know that this is going to have to, I'm going to have 2 brackets, because when I factor, I'm taking a sum and making it into factors, a product. So let me look at this. I'm going to do the easier one first. So I'm going to look at this factor of 3. So because I have a 3 here, this tells me that I'm going to take my x value and I'm going to add 3. So in other words, the 3 that I have here is coming because of this 3 that I have up here. Now the next bracket is a little trickier. Here's what I need to do. I look at what I have in the denominator, if it's a fraction, and that becomes the coefficient of my x. So in other words, because I have a 2 in the bottom, that means I have a 2x up top here. And next I need to look at what's in my numerator, and it's a 1. And so that means that I'm adding 1. If it was negative, I would subtract 1, but here I have a positive 1, so plus 1. And so there, I've done it. Okay? So to revisit this, and we'll do, I'm going to show you both methods when we do our practice examples, right? So again, I find my 2 numbers here. Here are my 2 numbers. I divide by the coefficient of my squared term, and then I use those to form my factors. One thing I do want to add is that you want to reduce any fractions. So let's add that in. Reduce any fractions to lowest terms. There we go. So what I'm going to do here is I'm going to factor showing both methods. All right, and so since the first 2 steps are the same for both, we're going to be able to kind of use some of the information from one method to help us with the other. So when I look at this, I can see that I am looking for a common factor. It's already written in descending order of degree. So now I'm looking for a common factor. So 2, 11, and 12 do not have a common factor, numerical common factor, and not every term has an x. So there is no common factor to remove. So I'm ready to move on to my next step, which is to find 2 numbers that will multiply to give me the product of my first and last term. And so 2 times 12 is 24. So I'm looking for 2 numbers that multiply to give me 24, but also add to give me that middle term, which is 11. Okay, so if you need to, pause the video now to think about what those numbers are, to work through your factors. I've already done this, and so I know that the numbers I'm looking for are 8 and 3. And 8 and 3 work in both scenarios, so I've found my factors. Okay, and so I'm going to try to do this over on the side so I have enough room. So when I look at this, I'm going to, take my middle term and I'm going to decompose it into 8x and 3x. So let me do that. 2x squared plus 8x plus 3x. And then I still have my plus 12. Okay, so here I have the same as my middle term just decomposed. Okay, now the next thing I need to do is to factor by grouping. And so I'm going to take the first 2 factors and the last 2 factors. And to factor by grouping, I need to remove the common factor from both sets of brackets. So in my first bracket, I can see that there's a 2 and an 8, so I'm going to pull out the 2 as my numerical coefficient. But I also need to explore the possibility of there being a variable that they have in common. There's x squared and x, so that means that I can pull out an x. Now let's look at what the leftovers are. I pulled out 2x, and so that leaves me with 1x left over. And now I have my second term here. I have 8x, and so 2 times 4 is going to give me my 8 back. And then I also pulled out the x, so I don't have an x in there anymore. So I know that I have, oopsies, plus 4. Now let's do the same with my second bracket. So I have a plus here, so plus. I'm going to remove the 3 because I see that they have a common factor of 3 that I can pull out. That's going to leave me with x plus 4. At this stage, I can see that my brackets are the same, which is a good indication that I've done things properly at this stage. So let's pull out that x plus 4. And then my remainder is 2x plus 3. Okay, so that is my decomposition method, and I can always FOIL it to see if I end up with what I started with. Okay, let's try method number 2. So method number 2 involves me taking those terms, the 8 and the 3, and dividing by the coefficient of my squared term, which is 2. Okay, I'm going to see if any of these are actually divisible, and so I know that 8 divided by 2 gives me 4, so I'm going to keep that as 4. I know that 3 halves can't really be, 2 doesn't divide into 3 evenly, so I'm going to keep that as 3 halves. Now I'm ready to make my brackets. Okay, and so remember that the 4 here alone tells me that in my first bracket, and remember I need 2 brackets, I'm going to have an x plus 4. Because it's not in fraction form, the coefficient of my x is a 1. And I guess I could think of that as being 4 over 1. But anyway, so to get my second bracket, the coefficient of my x term becomes whatever is in the denominator, so 2x. And then whatever is in my numerator becomes what gets added to that 2x. In this case, it's a 3, and so I'm done. And so if you look here, I have the same exact solution, and so both methods work. Let's try another example, and I'd like you to try this on your own using whichever method you feel most confident in. Okay, take a minute to give this question a try, and when you're ready, I will go through it. All right, so I'm ready to take a look at this. So I'm going to start with what these questions have in common, which is to check for a common factor. There is no common factor here to draw out, and so that is accomplished. It's also in order from highest degree to lowest degree, so that is accomplished for me as well. So the next step on my list of things to do is to find out 2 numbers that are going to multiply to give me the product of my first and last term, and also add to give me my middle term. So the product of my first and last term, 4 times negative 6, gives me negative 24. And then my middle term is 5. And so when I think about this, I am thinking, okay, well, 8 and 3 somehow will work. And let me think about where the negative needs to go in order to end up with a positive 5. It looks to me like the 3 needs to be negative, and that will give me a product of negative 24. So there, I found my 2 numbers. So I'm going to do this using the decomposition method and then the simpler quick trick method. So let me create a little divide here for both of those. So I'm going to break down my middle term, 5x, into 8x, so positive 8x, and then minus 3x, using the numbers that I have over here that I figured out, and then minus 6. So next I'm going to factor by grouping. So I'm going to group these 2 guys together, and then I'm going to group these 2 guys together. I'm going to remember there's a little plus in between here when I have the negative inside the bracket. So then I pull out the 4, and I can see that I can pull out an x as well. Don't forget to do that. And then my leftovers are going to be x plus 2. And then in my second bracket, I'm going to pull out the negative. So negative 3, and that's going to leave me with x plus 2. And at this stage, I can see that my two brackets are identical, which gives me the impression I've done this right. So I'm going to pull out that x plus 2, and then that leaves me with my leftovers 4x minus 3, and now I've factored it properly. All right, let me do it the quick trick method in case you decided that that was your preferred method. So I'm going to take my two values. I have 8 and I have negative 3. And I'm going to divide those by the coefficient of my first term, which is 4. And when I look at this, I end up with 8 divided by 4. Those divide evenly to give me 2. 3/4 does not divide evenly, like 4 doesn't divide evenly into negative 3. So I'm going to leave that. So these are the two things that I'm going to use to create my two brackets in order to factor this. So the 2 alone tells me that my first factor is x plus 2. And then the negative 3 over 4, well, that 4 tells me the coefficient of my x. And then the negative 3 tells me I'm subtracting 3 in that factor. And lo and behold, I've got my two answers that are identical, which means that both methods work in the same way to get me a correct solution. Hope you did okay with that. Let's move on to another example. All right, here is your next example. Write it out, pause the video, give it a go on your own, and then we'll come back together. All right, so let's take a look at this question. I'm noticing right off the bat that it's already in descending degree, so it's in the correct order. And that, there is no common factor. This 19 kind of gives me the idea that I'm not going to be able to pull out a common factor there. So my next step, sorry, I'm just eating a carrot right now, is I'm going to find two numbers that multiply to give me, well, what is 6 times 15? That is 90. Ugh, that's kind of ugly. And I want two numbers that will add to give me negative 19. Oh, maybe it's not so ugly. All right, so I always, when it comes to, numbers that are multiples of 10, I kind of like to see, I like to try that out first. And so I know that, 10 and 9 can work together to give me 19. Since I have negative 19, that means that both the 9 and the 10 have to be negative, and that works to give me my positive 90 as well. So those are my two values. All right. So let's separate my screen here, and so I can do both methods. So I'm going to do the decomposition method first. So I'm going to decompose my middle term into negative 9 and negative 10. So minus 9a and minus 10a, and then plus 15. So I'm going to group them, okay? And these guys are grouped together, and then these guys are grouped together, and there's like a plus in between here. So then I pull out, I can see between 6 and 9 that I can pull out a 3, and they have an a in common, so I'm also going to pull out that a. And that will leave me with 2a minus 3. And let's look at my second bracket. I'm going to pull out negative 5. So negative 5, and let's see what that leaves me with. That leaves me with, oopsies, 2a, and then minus 3 again. Now, don't watch this because, I know that negative 5 times negative 3 will give me positive 15. So if I'm drawing out that negative here, I have to make sure that I remember to make whatever's left over negative as well to end up with a positive 15 at the end. So that's, not an uncommon mistake. And when I pull out the negative, I can see that my two brackets end up being the same. And if I don't pull out the negative, the brackets aren't the same. So, that's another hint in terms of whether to pull out that negative or not. Let's go back to the solution. And so I know that there's the 2a minus 3, and then there's the 3a minus 5, and now that is fully factored. I'm going to go about doing this using my quick trick. So I've got negative 9, and I've got negative 10. And I'm going to go ahead and I'm going to divide that by the coefficient of my squared term, which is 6. Okay, this is not so pretty, people. Neither of these values, the negative 9 nor the negative 10, can be divided evenly by 6. But I still need to remember to reduce my fractions. So I'm going to reduce this fraction to be negative 3 over 2, remembering that both 9 and 6 can be divided by 3. And then I'm going to go ahead and do the same thing with my second fraction that I end up with. I can see that, 5 is always a good, or 2 is always a good one to start with when both my values are even. So, I know that both negative 10 and 6 are divisible by 2. And so that will give me negative 5 over 3. And those are in their lowest forms. So remember, now I'm going to use this and this in order to get my two brackets. And so the 2 on the bottom here tells me that I've got to put my 2x in front and then minus 3. And then the 3 on the bottom here tells me I've got 3x. And then the minus 5 on the top here tells me I have minus 5, and I'm done. Oops, except that I've used x's instead of a's. That is my mistake. A, and now I can see that my two solutions are the same. Hopefully you did okay with that, and hopefully now you're starting to figure out, well, what method is the one that you prefer, and then you're going to make a choice there. Okay, let's try another example. So write it out, give it a go, and then we'll come back together in a little bit to try it out. All right, so let's take a look at this question here. So let's make sure we check to see, is it in descending order? Yes, it is. It's in the correct order. Next thing I need to do is I need to look to see if there is a common factor. And so I know that 10, negative 22, and 4 are all divisible by 2. So I don't know if you caught that, the fact that we needed to remove the common factor of 2 before moving on. So, oopsies. So now that we do that, you should end up with 5b squared minus 11b plus 2. And the bonus is now we're not working with these larger numbers. At the end, if you didn't remove a common factor, the two factors that remain would have the need to remove a common factor. So you could work with bigger numbers at the beginning and then remove a common factor at the end, and that will work fine as well and give you the correct answer. But I prefer to just work with these smaller numbers. So I'm going to kind of prep myself here. Right now I'm just going to do the decomposition method, I think. And so I'm prepping knowing that I'm going to have two brackets here. Now on our last quiz, some of you forgot to remember to kind of transfer the common factor that you pulled out to the next line. You need to do that or else your solution is incorrect. So make sure that you're watching for that. So back to business. I know that I'm looking for two numbers that will multiply to give me 5 times 2 or 10, and two numbers that will also multiply, oopsies, to give me negative 11. That will add to give me negative 11. And so I'm looking at this and I'm thinking negative 1 and negative 10. Negative 1 and negative 10, and yes, that works. So I'm going to decompose my middle term before I do anything else. So let me get rid of some of this business. I know eventually I'm going to need those brackets, but not yet. So I'm going to write, okay, well I have my 2 bracket 5b squared. I'm going to decompose my middle term by writing minus 10b and then plus 1b and then plus 2. And again, I'm just decomposing that middle term, negative 11b, into these, two factors. Just notice that this needs to be a negative. So that would have been a lot of work for nothing. There we go. All right, so now I'm going to create some little groups. I think I'm going to group these guys together, and I'm going to group these guys together, plus in between. And let's go. So I'm going to move that 2 down here. I'm going to factor by grouping. I'm going to put the big square bracket around that. I'm not sure if at any point in time you've learned about the conventions, how the first set of brackets are the rounded ones, but then if you need a set of brackets outside of that, then they suddenly become square. That's not really a big deal at this stage to me, but it is something that you will see, and it is good form, so if you're looking to have top form, that's what you ought to be doing. All right, back to my factoring by grouping. So between the 5 and the 10, I'm going to pull out a 5, and I also have a factor of b in each of those terms, so I'm going to pull out 5b as a common factor. That will leave me with b minus 2 in my first bracket. Now let's take a look at this second here. I'm going to pull out the negative 1 in my second bracket, and that will allow me to have positive b, or just 1b, and then minus 2. And so let's look at that again, because that is a little bit tricky with those negatives. So again, if I pull out the negative right here, right, then I divide negative 1 by negative 1, it leaves me with positive 1 beside my b. And if I pull out the negative 1 out of my positive 2, well, negative 1 times negative 2 is going to give me back my positive 2. So that is why that 2 needs to be negative here. And look, by doing that, I can see that my two brackets are the same, and so I'm good to go. So let's carry on. This was a tougher example. I'm going to keep my 2 out there. Now my square brackets don't need to be there because I'm going to pull out my b minus 2, right, that they have in common, and then write the leftovers, my 5b minus 1, and now I'm done. Okay, so that is what I would do using the decomposition method. I'm going to erase some of this and then give it a go using the quicker method. So using my decomposition method, I have, my negative 1 and my negative 10. And now I'm going to divide them both by that coefficient of my squared term, so that's 10. Oopsies, what did I forget to do, people? I forgot to remove my common factor, so let's do that. Okay, so nothing changes with respect to that. I'm pulling out my 2. I still have 5b squared minus 11b plus 2. Okay, so the numbers that I chose are based on what's inside my bracket. So, the 2 still needs to kind of be there. And then I'm going to brace myself for what's coming in my brackets. So on the side, let's go back to those numbers. I have negative 1 and I have negative 10. But what changes now with my quick method is instead of using the 10, I need to use the 5 because that's what was left over, and that's the trinomial I'm actually factoring. So negative 1, this is a 1, that's from this one up here, and negative 10, that's from this 10 up here, both divided by 5. And when I reduce those, I end up with, well, there's nothing to be done here, and then I end up with negative 2. So my brackets are 5x minus 1 and x minus 2, and I'm done. Okay, one last practice question, and there will be no homework today. Today, your only job is to work through these questions, and then tomorrow we'll have a work period to kind of consolidate. So here's your last question to try. Okay, so let's see how you did with this. So I know that, even though there is a y squared here, instead of just a constant, that the process will be the same. But if you were confused about that, let's go through this together and ensure that you're okay with it. So I don't see any common factors, and it is in the correct order. I see my middle term is a combination of the two variables, which makes sense. So I'm going to figure out what my product and sum need to be. So I need two numbers that multiply to give me negative 24, but also add to give me negative 5. And so I see 8 and 3 are separated by 5. So I know I'm going to have to fiddle with those somehow and put negatives where they belong. So since negative 5 is the sum, my bigger value needs to be the negative, so it looks like it's negative 8. And those numbers work. All right, so I again want to do this both methods, so feel free to fast forward if you did not do it the decomposition method. So I'm going to kind of break up my middle term. So 4x squared. minus 8xy plus 3xy. And notice that it's an xy because my middle term was an xy. Okay, and then I have minus 6y squared. So I'm going to group these. I'm going to put these two guys together and put these two guys together and pull out any common factors in my next group. So in my first set of brackets, I have a common factor of 4x. And then my leftover becomes x minus 2y. And then let's look at my second bracket. My second bracket looks like I can pull out a positive 3y. And that will leave me with x and then minus 2y again. So that's great because my brackets are the same. So I'm going to pull out my x minus 2y in front and then write the leftovers in my second bracket, the 4x plus 3y, and I'm done. Now I'm going to do this the quick trick method. So I've got negative 8 and I've got 3. I'm going to divide by the coefficient of my first term, which is 4. And I'm going to see what I get if I can divide any of these evenly, and I can. So negative 8 divided by 4 gives me negative 2. And it looks like I'm stuck with my 3/4 because 4 doesn't divide evenly into 3. So now I'm going to write out my two brackets. My first bracket, since it's not a fraction, I simply get x minus 2. But here's the trick. Now, in order to get a y squared at the end, I need to have a y and an x in both brackets, right? So it's going to be x minus 2y. And now let's look at my second factor. I've got 4 here, so 4x, and then plus 3. And now I put my y in ahead of time, but in order to make sure that I end up back with my y squared, I needed to have a y in each of the second terms of each binomial. So hopefully you did okay with that. Notice again that I end up with the same result using either method. And I'm going to just post a little voting thing on Google Classroom to see which method you seem to be leaning towards, because I'm just kind of curious. Anyway, here's the video. Hope you enjoyed. We'll spend more time tomorrow practicing and consolidating some of these skills because it's a big jump. All right, see you tomorrow. Hopefully.